Dear students, in this video I explain memory decoding. This is very simple and very small concept. Memory decoding. The memory decoding is nothing but the memory IC used in a digital circuit is selected and enabled only for a range of addresses assigned to it, and this process is called as memory decoding. The memory IC is disabled for the particular range of addresses that are not assigned to it. So this is enabled only for assigned addresses, and it is not enabled for the addresses not assigned the this memory. So that is nothing but memory decoding. In addition to requiring the storage components in the memory unit, there is a need for decoding circuit to select the memory word specified by the input address. So in addition to the requiring the storage components in a memory unit, there is a need of decoding circuit to select the memory word specified by the input address, so that the decoding circuit is required to specify the memory location in the memory organization. So an example for two-dimensional constant decoding arrangement is shown in below figure, which shows the more effective decoding scheme that is used in the large memories. So here two-dimensional memory decoding is explained. So two-dimensional means x and y dimension, x and y. So horizontal dimension is nothing but x, vertical dimension is nothing but y. So this is 5 into 32 decoder. 5 inputs are having 32 outputs, 0 to 31. These are the output lines for this decoder. And y dimensional decoder having again 5 inputs and 32 outputs that are 0 to 31. These lines are nothing but 32 outputs of y decoder, y dimensional decoder. These are the outputs of x dimensional decoder. These are the outputs of y dimensional decoder. So now we want to locate or decoding the particular data or particular location of data. So I want to locate this data, this binary address or this binary data. So first we have to identify this binary address. After that we can get the data from this address. So the binary address for this location is for the suppose x value. So this is the line 12. This decoder output line is 12. This decoder output line is 20. The coincidence of this point is x-axis decoder line is 12, y-axis decoder line is 20. So that x-axis represents 12, 0, 1, 1, 00, and y-axis represents 20, 1, 0, 1, 00. So that is the binary representation address location of this particular address. So if you identify this address, we can get the data from this point. So x position is 10011 and y position is 1011. So this is the address for this location. So that is the decoding structure for 1 kilobyte word. So hence using a single 10 into 1024 decoder also we can locate, but we are using two 5 into 32 decoders. The 5 most significant bits of the address so related to the x, and 5 LSB bits are located related to the y. So that in this address, so most significant bits are there, least significant bits are there. So the most significant 5 bits are represented for x direction. The least significant 5 bits are located for the y direction. So that is represented here. So 5 LSB goes to the y. In each word in the memory array is selected by the coincidential of one x line and one y line. Each intersection represents a word that may have any number of bits. For example, consider the word whose address is 404. Now we want to locate the word, or we want to identify the word, the location of that word address is 404. Now we want to decode the memory or the data which was present in the 404 address line. So the binary representation or binary equivalent value for 404 is 01101010100. This can be split into two ways or two representations, x and y representation. So already we say first MSB and LSB. So 5 bits of MSB, from MSB first 5 bits are represented for the x direction. From the LSB, 5 bits are located for the y direction. So MSB is this one, LSB is this one. So first 5 bits for the MSB, that means 0 1 1 0 0 1 1 0 1. So that is y. So this is x direction. So this makes x is equal to 0 1 1 0 0 0 1 1 0 0 1 1 0 that locates the x direction. So MSB of 5 bits locate for the x direction and LSB of 5 bits locate for the y direction. LSB 5 bits are like this 1 0 1 1 0 1 1. So 0 1 1 0 in binary representation, in decimal it can be represented as 12, and y value 1 0 1 0 this can be represented as 20 in decimal. So the location for this 404 address is, so this one, in x direction 12 in decimal, in y direction 20 in decimal. So this is the location for that particular address. So from this address we can get the or decode the memory. So this is the concept of memory decoding.